Our examples thus far have dealt with variables and variable expressions as well as real numbers containing positive integer exponents. This next slide here will discuss exponents that are 0 and are negative. For any number that is raised other than 0, we don't 0 to the 0 power, that is a calculus concept. Let's discuss the regular concepts before we get there. Other than 0, any number that has an exponent of 0 is understood to be the factor of 1. That's what our first property says. If you have 0 factors of a, you have nothing. If you have 0 factors of a, there is no need to write down a on the board because there is no factor of a. So what are you looking at? Understandably, you're looking at 1. Property 2, any negative exponent really is just letting you know that you're dividing by that expression. In other words, a to the minus m is understood to be defined as 1 divided by a to the m power. So the negative exponent is called our reciprocal exponent. In other words, change the minus sign to a positive sign and then divide by that expression. That's what a to the minus m is telling you to do. Likewise, we'll see in just a moment that if you have a to the m, if your exponent m happens to be negative in your denominator, you can make it positive by placing it in your numerator. We'll see that on the first example. Number 3 says if you have a fraction raised to a negative exponent. Again, the previous property 2, the reciprocal rule, says if you take a fraction with a negative exponent, the reciprocal of a fraction is flipping the numerator and denominator. So a fraction with a negative exponent is equal to the reciprocal raised to the positive exponent. In other words, a over b to the negative m is equal to b over a raised to the m power. Let's look at some examples here. Rewrite the expression using only positive exponents. That's how we know an expression is simplified. Only when it contains positive exponents and when the base is written only once. Look at number 62. You notice that factor of u, that base of u, is displayed twice in the expression. We only need it there one time. We need to find a way to simplify that down to just one base of u. Whatever the exponent is, we'll have to determine that. Also notice there are negative exponents present. We do not want negative exponents. Notice there, only positive exponents. That is when we know we have a simplified expression. Let's go ahead and write this up. 6 multiply u to the minus 2 power. This is divided by This is divided by 15 times u to the minus 1 power. Go ahead and go to the full view here. As you're going to see throughout this section and throughout the course, when simplifying an expression, there are many ways to begin this process. I already look at this and see 2 or 3 properties that I can begin with here to simplify this expression. Already we have looked at the quotient rule that allows us to take these factors in the numerator and denominator and divide them by their respective common or like bases. 6 divided by 15, well, because these are real numbers, we can look to simplify this expression. U to the minus 2 exponent divided by u to the minus 1, according to our quotient rule of integers, we can simplify this. Let's go ahead and do so. How do you simplify a fraction? How do you reduce down a fraction? Why do we know that 4 over 8 is 1/2? Well, mathematically speaking, it's because there are common factors that are shared with our numerator and denominator. Think about prime factorization. How can you rewrite 6 in terms of prime factors? What times what times what will give you 6? What numbers can you plug in that will multiply to give you 6? What, 2 times 3? Right? 2 multiply 3 is 6. Repeated addition, 2 plus 2 plus 2 is 6. Likewise, 3 plus 3 is 6. What about 15 though? That's the product of 5 and 3. See here that because the 3 is in both the top and bottom, they cancel. leaving us with 2 divided by 5. Another way to view this, why can they cancel? If you move the factors in the denominator around, right, 5 times 3 is still 15, but now, as we've done over here, we can take the factors top and bottom and break them apart as fractions. So 2/5 is multiplying the fraction 3/3. What is 3/3? If I have a third of something, but I have 3 of those, I have the whole thing. If you have a third of a pizza, but you have 3 slices of a third of pizza, you have a full piece of pizza. You have 1 pizza. 3 divided by 3, any number divided by itself is 1. Now this is the same thing as the fraction 2/5 multiply 1. And we know that 1 times 2 over 5 is just 2 over 5. Because when you multiply by 1, it's not changing anything. This is going to be a really big, important deal for us later on when we need to introduce multiplying by 1. Anytime you want, if you need a factor to be in an expression, you need that factor in there. We'll just take that factor and multiply it to the numerator and denominator. And what have you done? You have successfully multiplied by 1. I can take the fraction 2 over 5. If I only have 5 people and I need to hand you 2 things, I can do that. But what if 15 people are there? How many things do I need to hand out now? Well, I can build up this fraction as 6 over 15. So if for each 5 people you get 2 pizzas, what if you have 15 people? Well, building up that fraction, you see that for 15 people, you need 6 pizzas. That's just the way that ratios work. Ratios allow us to see fractions as bigger than what they really are. 6 over 15 looks really big, but it's really just 2/5. 2/5 allows us to see that that's 40% of a number, because that's the way that fractions, decimals, and percentages work. It's awesome. Okay, let's move on. 6/15 is the same as 2/5, but what about right here? Our quotient rule says base u with exponent minus 2, subtract, because it's a quotient, we're subtracting. -2 is going to subtract -1. There's my exponent, -2. There's my exponent, -1. Because they're dividing, I must eliminate by subtraction. So the question here is, how do we subtract negatives? Remember, -2 subtract -1. We are going to leave this number the same. We're going to change minus to plus. And we're going to change this negative number to a positive number. -2 minus -1 is -2 plus 1. If I have -2, if I'm at 0, I start at -2, but then I add 1. I'm moving up closer to 0, so I'm at -1. So my exponent is -1. U to the -1 power. So this becomes 2 over 5. This becomes u to the -1, so I need to multiply. Keep in mind, 2/5 multiply u to the -1. I can rewrite this, and I can take u to the -1 and place it in the numerator. It's just more pleasant to see this little lonely denominator of 5. We'll just take this and plug it under the real number 2. But just to let us know, these two expressions are exactly the same. 2/5 times u to the -1 can be expressed, because what is u to the -1? It's understood to be a fraction divided by 1. Oh, that's so cool. Any number is understood to be divided by 1. Therefore, any number can be seen as a rational number like this. U to the -1 divided by 1 is simply u to the -1. But a fraction times a fraction, you multiply straight across. 2 times u to the -1. 5 times 1 is 5. And there we have our single fraction there, 2u to the -1 all over 5. But what do we say? We do not want negative exponents. They need to be positive. Our PowerPoint rule here says a to the -m power is equal to 1 divided by a to the positive m power. I have u to the -1. I need that to be positive 1. To make it positive, I need to take u to the -1 and place it into my denominator. Take u to the -1, plug it down here. And when you do so, you change the -1 to a +1. So the 2 and the 5, my real numbers stay exactly where they are. 2/5, that fraction doesn't change. U to the -1, however, the exponent is negative when it's in the numerator. So to make it positive, we need to place it in our denominator. The -1, when placed in the denominator, becomes +1. And of course, any number to the first power, we do not have to write that exponent of 1 if we don't want to. It's understood that 2 is to the first power, but we just write 2. 5 is to the first power, but we just write 5. 2 over 5 times u is our simplified expression. I want to show you one more example, one more way we could think about this. I kept saying that if the variable's exponent is negative, make it positive by switching its position. U to the -2, well, that -2 can be positive if I place it in the denominator. U to the -1, well, that -1 can be positive if I place it in the numerator. Leaving the 6 and the 15 the same, the factor of u to the -1, let's move it to the numerator to make it positive. U to the -2, let's take it and move it to the denominator to make it positive. These two expressions represent the same exact number. I challenge you to put any number for u into your calculator and see if these expressions give you the same value. They will. U to the -2 is the same thing as 1 divided by u squared. We're dividing by u squared, so it's down here. U to the -1 is the same as 1 over u. Well, how can I place u down here in this denominator? I move it to the numerator. So when the exponents are negative, to make them positive, just switch their position from numerator to denominator, from denominator to numerator. And let's see what we get here when we simplify this. We already know what the fraction 6 over 15 will simplify to. It's 2/5. There's our fraction, 2/5. But what about over here? 6 is multiplying one factor of u. Well, now it's a 2 because we canceled the factors of 3. What about over here? U squared is u times u. A common factor of u in the numerator and denominator. And as we see, we get our simplified fraction just as we did before, as we should, 2 over 5u. 5 multiply s to the 5th power, multiply t to the -5 power. That is multiplying -6 times s to the -2 power times t to the 4th power. So it's almost like if we just drop the parentheses for number 68, everything's multiplying across the board. 5 multiply s to the 5th, multiply t to the -5, multiply -6, multiply s to the -2, multiply t to the 4th. Everything's multiplying, so we will use our commutative property to move around these factors. 5, just to see this again, 5 is multiplying s to the 5th, which is multiplying t to the -5. This is now multiplying the -6. We're not subtracting 6. We're not subtracting over here. We're multiplying by the -6. So you see here, 1, 2, 3, 4, 5, 6 individual factors here. Now, of course, we can break these apart. S to the 5th, that's 5 factors of s. T to the -5, again, what does that mean? We don't have 5 factors of t. This is 5 factors of t. T to the -5 means something different. It means we are going to divide by 5 factors of t. Remember, that's what our negative says. We can rewrite this using our negative exponent rule. 1 over t to the 5th power. That's what this represents. Any negative exponent, you're really going to now divide by that expression. Divide by t to the 5th. S to the -2, we don't have 2 factors of s. We're going to divide, however, by 2 factors of s. So now I have 5 multiply s to the 5th, multiply 1 over t to the 5th. So in other words, at some point, let's divide by t to the 5th. Let's then multiply -6. Let's then divide by s squared. right? 1 over s squared means to divide by s squared. And let's multiply by t to the fourth. So all this going on here, multiplication, but this right here, 1 over t to the fifth, we can say that we're multiplying by the fraction 1 over t to the fifth, or we can view this as dividing by t to the fifth. Let's go ahead and continue to break this up. Because it's commutative, we're going to multiply the real numbers together. 5 times 6 is 30, so 5 times negative 6 is negative 30. Here we have s to the fifth. Here we have 1 over s squared. Let's move them together. Remember, we're saying 1 over s squared is to divide by s squared. So s to the fifth divided by s squared. And we've already taken care of the 5 and negative 6. Multiplies to give us negative 30. S to the fifth divided by the s squared. We have it here. And now t to the fourth power. If t to the fourth power multiplies 1 over t to the fifth power, it's the same thing as dividing by t to the fifth power. So now let's just look to simplify. Negative 30 is multiplying this ordeal here. 5 factors of s divided by 2, we're eliminating 2. 5 minus 2 is 3. So we still have 3 factors of s. Now what's going on here? I have 4 factors of t, but I'm eliminating 5. I'm dividing by 5 factors of t. Well, how many do I leave behind, right? There's 4 here and there's 5 here. Well, 5 minus 4 is 1. Is it this, though? Can't be this, because I have more factors of t in my denominator than I do my numerator. So where does this factor of t go? Where does it go? It goes in the denominator. I have 4 factors of t up here. I have more factors of t down here. So when they cancel through elimination, there's 1 factor of t that will remain down here. And there it is. Another way to think of this is our quotient rule says subtract exponents, numerator minus denominator. 4 minus 5 is negative 1. T to the negative 1, in this case here, t to the fourth divided by t to the fifth, t to the negative 1, is expressed as 1 over t. Remember, what does the negative exponent mean? It means that t to the negative 1, we're going to actually take 1 factor of t and divide by that factor of t. And that's what we get over here. T to the negative 1, which is defined to be 1 over t, says we are going to divide our expression by t. And that's what we have here. If we don't write it out like this, if we don't think of it like that, then when we get to this step at least, here's your minus 30, multiplying your s cubed, multiplying your 1 over t. Well, any number times a fraction, this number here can be understood as being over 1. Any number divided by 1, you're just going to get back that number. Negative 30s cubed divided by 1 is simply negative 30s cubed. But this allows us to now multiply the fraction 1 over t. In our numerator, negative 30s cubed times 1 is negative 30s cubed. However, in our denominator, 1 multiplied t is simply t. So regardless here, we get our simplified rational expression, negative 30s cubed divided by t. 76, we are looking at the quantity 5 squared times x cubed times y to the negative 3 divided by 125 times x times y, and that rational expression is being raised to the exponent minus 1. On the inside of our parentheses, although we have a negative exponent on the outside, let's go ahead and work with the inside, simplifying whatever we can on the inside of our parentheses and work towards the outside. That's how we want to think about algebra when we look to simplify. what is the innermost expression that we can simplify and work our way to the outside? Here, we have an exponent attached to our fraction, but is there anything we can do for the numerator and denominator to further simplify? Immediately we see here we have 5 with exponent 2. 5 squared, or 5 times 5, is 25. So already we've taken care of a step here by rewriting the 5 squared as 25. Again, only looking inside the parentheses, we have 25 multiply x cubed, which is multiplying y to the minus 3 power. And the denominator 125 is multiplying the x, and that in turn is multiplying the y. So all these factors in our numerator and denominator. But in our numerator, I can't simplify the 25 with the x, with the y. In the denominator, I can't simplify the 125 with the x with the y. But I can jump up and down and simplify the 25 with the 125. I can simplify the x cubed with the x. I can simplify the y to the negative 3 exponent with the y, using our quotient rule for exponents, as well as using our rule for simplifying fractions. The factors of 25 and 125, when divided together, are going to multiply the fraction x cubed over x, which will multiply the y to the minus 3 over y factor. All of this, of course, has this outside exponent of negative 1. So we're working on each individual factor. We know that we want, if we have a number, the variable x and the variable y, in multiple places, then we just need one factor that is a number. We need one factor that is a variable x. We need one factor that's a variable y, or at least rather one base. 25 divided by 125, well, what's that? I know if we spun this around, 125 divided by 25 is 5. Because I know if I have 5 quarters, that's $1.25. So 5 quarters is $1.25, therefore 25 will divide into 125 5 times. But we have the opposite here. We have 25 divided by 125. It won't give us 5, but it'll give us 1/5. Again, think about the factorization. 125 can be rewritten as 25 times 1. 25 times 5. So the 25 factor that lives inside of 125 can actually cancel with the 25 in the numerator. When the 25 here cancels, it leaves behind simply a 5. 25 is 25 times 1. So when the 25 cancels, we leave behind the factor of 1. X cubed divided by x, 3 minus the 1 factor is x squared. Y to the negative 3 divided by y, again, it's understood to have an exponent of 1. Negative 3 subtract 1, negative 3 minus 1. So here's 0, minus 1, minus 2, minus 3. If I'm at negative 3 and I subtract 1, I go even smaller, negative 4. So what do we have here? We have 1/5, which is multiplying x squared, which is multiplying y to the negative 4, and all of those factors share the exponent negative 1. So each factor in parentheses will actually gain the exponent negative 1. The 1/5 will be raised to the minus 1. X squared will have the minus 1 power. Y to the negative 4 will have the minus 1 power. I have a fraction with a negative exponent. Let's go back to the PowerPoint. Let's look there at number 3 property. Property 3 says if I have a fraction with a negative exponent, If I take the reciprocal, if I flip the numerator and denominator, I can change the sign of the exponent. 1/5 as exponent -1, flipping that fraction, I get 5/1, and my exponent -1 becomes +1. X squared is being raised to the -1, multiplying the 2 and the -1, -2. -4 multiply -1, +4. So now we need to look to simplify this. 5/1 to the first power. Well, first off, 5 divided by 1 is just 5. 5 to the first power is 5. What does it mean to have a negative exponent? X to the -2 means we are going to divide by x squared. The factor y to the 4th, because the exponent's already positive, it will be placed in our numerator. And we have here our simplified expression. Note, it's simplified because our exponents are both positive, and each base, x, y, and the real number, is only seen once. 2x cubed, y to the -4, all raised to the -3 power. This is multiplying 4xy to the -6 power. We have the factors 2, x cubed, y to the -1. These factors are raised to the -3 exponent, so we will raise each factor to the exponent -3. Everything in this parentheses gets this exponent -3. What about on this right parentheses? 4 multiplies x multiplies y to the -6. There is no exponent attached. There are no additional bases of x or y. There's nothing we can do to 4xy to the -6. They're just simply all multiplying together. All right, just to kind of rewrite it where they're separated, yes, we can combine them, 4xy to the -6, but what does that mean? It means that they're multiplying together. The -3 exponent means that we don't have 3 factors of 2. It means we're going to divide by 3 factors of 2. In other words, we express this as 1/2 to the 3rd power. X cubed raised to the -3, multiplying exponents, we get -9. Y to the -1 exponent raised to the -3 exponent, our power to a power, multiply -1 times -3, +3. This, of course, is multiplying 4xy to the -6, so we list them out as factors. Multiply the 4, multiply the x, multiply the -6 exponent of y, which again, what does it mean here to multiply by y to the -6? It means to divide by y to the 6th. So just as we did here, 2 to the -3 is 1/2 cubed, y to the -6 is 1/y to the 6th. Now we can take our real numbers and place them together. Oh, which by the way, 1/2 cubed, what's 2 cubed? We can simplify that. If 2 to the 3rd power, 2 times 2 times 2 is 8, 2 to the -3 power isn't 8, but 1/8. X to the -9, we do not have 9 factors of x. This tells us to divide by 9 factors of x. In other words, we have an expression here, 1/x to the 9th power. So now what can we do here? Let's bring together the real numbers. 1/8 multiply 4. 1/8 multiply 4, or asking ourselves, what is 1/8 of 4? We'll get to that in just a moment. Y cubed, let's go with the x's here. Here's a factor of x, 1 over x to the 9. So I have a factor of x, but I'm going to divide 9 factors of x. I have 3 factors of y, but I'm going to divide by 6 factors of y. Let's take a moment there to see how we would want to simplify this product and how we would use our quotient rule to simplify these expressions. 1/8 multiply 4, or 4 divided by 8 is 1/2. The way that we can see this, any whole number 4 can be written as a fraction 4 over 1. In our numerator, 1 times 4 is 4. In the denominator, 8 times 1 is 8. Our fraction 4/8 is 1/2, simply because 4 can be rewritten as the product 4 times 1, 8 as the product 4 times 2. The common 4's cancel because we cancel factors, things that multiply, leaving us with that fraction 1/2. So 1/8 of 4, or 1/8 times 4, is 1/2. X over x to the 9th. Well, again, x is understood to have a power of 1. 1 minus 9 is -8. X to the -8 power. 1 factor of x divided by 9, you're going to have -8 factors, or we're going to be left with the division of 8 factors of x. Y cubed divided by y to the 6th. 3 minus 6. 3 minus 6 is -3. So what does this mean here? We have rewritten this in such a way that only the base of x is used once, the base of y is used once. But our exponents are negative. Negative exponents means we are going to divide by that many factors. So my fraction 1/2, where my factor x to the -8, I want this to be positive, so I'll place it in our denominator. So we need to divide by it. We need to somehow divide by x to the 8th power. Same thing here. Y to the -3, I want that to be positive. We'll place it in our denominator. How else could we have come to this conclusion? Let's use the exact definition. X to the -8 is defined to be 1 over x to the 8th. Y to the -3 is 1 divided by y cubed, according to our rule here, property 2. We're using property 2 to rewrite x to the -8 and y to the -3. Now what happens? We're multiplying 3 fractions. When you multiply fractions, multiply together the numerators. 1 times 1 times 1 is just 1. 2 times x to the 8th times y cubed, they cannot simplify, so we will just write them as the factors. And we see we have our fully simplified rational expression.